Welcome back to the channel. Watch the video until the end, leave a like, and subscribe to the channel to support us. We have a new space telescope, and the James Webb has made such an improbable discovery in a galactic nebula that it seemed like it should never happen. The telescope has spotted planets so unusual that they amaze us regarding the possibilities of planet formation. The binary objects with mass comparable to that of Jupiter, or in short jumbos, are so out of the ordinary that they seem impossible. Once again, the James Webb Space Telescope surprises us with a discovery that revolutionizes our knowledge of the universe, and we are far from having explored everything. What else will James Webb show us? The telescope has the potential to detect life in space for the first time. But how do the jumbos relate to super-habitable worlds? When NASA was looking for a name for the new telescope, the choice fell on James Webb, a longtime NASA administrator and driving force behind the Apollo program. Even today, James Webb is synonymous with significant advances in humanity's ability to understand the universe. The telescope that bears his name is now pushing our exploration towards areas of the universe previously unknown. The mission of the new telescope is to illuminate the darkest corners of the cosmos and find answers to questions we were unable to solve with previous technologies. How was the universe born? Are there other worlds like ours? What do the lights of the night sky tell us about our place in the cosmos? The positioning of the new space telescope is much further from Earth compared to Hubble, at the Lagrange point L2, about 1.5 million kilometers from Earth. This strategic position, free from the constraints of Earth's orbit, allows the James Webb Telescope to observe the universe with unprecedented clarity and sensitivity thanks to its fine measurement sensors. For the first time, we can examine distant exoplanets in extremely detailed ways, thousands of light years away. Researchers have discovered a completely new category of planets that is surprising everyone. The binary objects with Jupiter's mass in the Orion Nebula are completely overturning our understanding of planet formation. These objects, in fact, seemed impossible, but they exist even though we had not yet been able to see them. The Orion Nebula, known to many astronomy enthusiasts, is a bright star-forming region located in the Milky Way. Being one of the brightest gas and dust nebulas visible to the naked eye, it holds the secrets of the birth of stars and planets. For astronomers, the nebula offers the perfect opportunity to study the processes of star formation and the early stages of planetary development. It contains many molecular clouds that collapse under their own gravity, continuously generating new stars around which planets form. Thanks to James Webb, we have discovered a completely new type of double planet, the binary planets, consisting of two Jupiter-like planets orbiting around each other in a strange dance. This peculiarity has been named Jupiter mass binary objects, or in short, jumbos. The jumbos are so unusual and rare that they completely overturn our understanding of planet formation. These pairs have somehow detached from their stars and orbit each other in the interstellar void, a fact in itself already bizarre. But even more astonishing is the number of these jumbos discovered, as many as 40 in a cluster in the Orion Nebula, a statistical anomaly that forces scientists to completely reconsider theories on planetary formation. The jumbos constitute almost a tenth of all the wandering planets observed by the JWST in this nebula, a rate of Jupiter-like binary systems that should not exist according to previous models and theories on the formation of planets and star systems. The second anomaly lies in the planetary dynamics that make these objects an enigma. According to the traditional view, planets form within the dust disks that surround young stars and usually remain in stable orbits around these stars. The existence of the jumbos freely wandering in interstellar space orbiting around each other challenges this theory. The unusual objects and their masses provide data that confound our current understandings of the forces and events that might have contributed to their formation. Scientists are trying to clarify how these massive planetary bodies were torn from their original orbits and why they dance in the universe as bound pairs. Gravitational interactions and perhaps even massive collisions might have played a role in their formation process. The frequency of the jumbos in the Orion Nebula statistically improbable, is comparable to the perfect coincidence of all the balls in a corner of the pool table after a shot. Scientists were surprised by this discovery, as if they were looking into a large ballroom where 40 pairs have gathered in a corner, all looking almost identical and dancing a completely different dance from everyone else present. This discovery is forcing astronomers to question previous assumptions, and to consider that perhaps we didn't know as much about the universe as we thought. James Webb has upset many of our current models of cosmic evolution through real observations, continuing to shake the foundations of cosmology and classical astronomy. These 40 pairs of jumbos might have formed in ways completely different from what existing theories predicted. They raise doubts about the reliability of the old astronomical laws and introduce new questions about how two Jupiter-sized planets can form a common gravitational center without being captured by a star. Initial explanations are trying to introduce new concepts that account for the dynamics of multi-body systems and other scenarios, like gravitational disturbances caused by close passages of other stars. The relative frequency of the jumbos indicates that these anomalies might be more common in space than we thought, suggesting that we should expect many more unusual discoveries. These findings open new perspectives for the search for extraterrestrial life, indicating a greater diversity and complexity of planetary systems than previously thought. There could be celestial bodies favorable to life more common in the universe than we currently believe. The work on the jumbos is likely to lead us much further in the evolution of planetary systems and might revolutionize our knowledge of our solar system. In this context of continuous discovery, we realize that we are just at the beginning of an exciting journey into the universe. The James Webb Space Telescope continues to work tirelessly, scrutinizing other corners of space, and scientists are developing further observation strategies to unravel the mystery of the jumbos and explore other regions of the universe. Other ground and space telescopes are studying the Orion Nebula and other areas to identify more dancing Jupiter pairs, while researchers are also interested in examining other star-forming regions to discover if similar anomalies exist. New discoveries could also revolutionize our understanding of our solar system. In recent years, evidence has emerged that the order of planets and moons might not be as clear-cut as once thought. Our moon could be considered a planet. Pluto and its moon Charon might turn out to be a dual planetary system, and there is evidence suggesting that Neptune might have had an interstellar origin. These discoveries are ushering us into a new era of cosmic research, where we are constantly surprised by what we find in space. The jumbos and mini-Neptunes have shown that the universe is full of wonders and surprises still waiting to be discovered. Our understanding of the universe is continually evolving through the efforts of researchers and advanced technology, like the James Webb Telescope. Join us on this exciting journey and be part of every new discovery that brings us closer to understanding the mysteries of the universe. With the James Webb Telescope and other advanced tools, we will continue to explore, discover, and learn, opening new frontiers of cosmic knowledge, and perhaps one day finding out if we are truly alone in the vastness of space.